The idea here is to demonstrate how to make the graph of an algebraic function. Graphs are nice because they allow us to visualize what is going on. Is the function negative, inverse, flat, going up, down? In other words, graphs of functions let us see how variation is taking place. This specific graph shows production over time, and this one learning over time. Both functions show the rate of change at different intervals or points. They also show the limits of the function. In any case, to make the graph of a function, we start with the standard coordinate system and plot the data using a table that shows both the independent variable x and the dependent variable y, where x is the domain and y the function of x, or range. For example, graph the function f of x equals x squared. We first build a table of values. When x is 0, the function of x is 0 squared or 0. When x is 1, the function is 1 squared or 1. When x is 2, the function is 2 squared or 4. When it is 3, 3 squared or 9. Now, going into the negative values, when x is negative 1, the function is 1 because negative 1 times negative 1 is 1. When it is negative 2 times negative 2 is positive 4. The value of x of negative 3 will give you the positive 9, and so on. Now, if we plot the coordinates of the various points found, we notice that the function is curved, that it begins at an undefined negative value, turns around at 0, and, never being negative, turns positive towards, again, undefined values. Now, if we want to know what is happening as it turns at 0, we have to find values for the function for fractional values of x, so that when x is 0.5 or negative 0.5, the function is 0.25 on both sides of the y-axis. 0.5 times 0.5 is 0.25. We now draw the line of the graph of the function f of x equals x squared. If we want to make the curve really smooth, then we would have to compute more points to certify that the function follows the shape of a parabola.